In this video, we're going to have a look at quadrilaterals. Quad is Latin for four and latus is side. So a quadrilateral is defined as a plane figure bounded by four straight sides and has four vertices. Common quadrilaterals are parallelograms, rectangles, squares, rhombuses, and trapeziums. There's two types of quadrilaterals, convex quadrilaterals and non-convex quadrilaterals. Convex quadrilaterals are where all angles, let's say all interior angles, are less than 180 degrees. As you can see in this figure, all interior angles are less than 180 degrees. And both diagonals, that is, if you join opposite vertices, so let's say there and there. So both diagonals lie inside the figure. Conversely, convex quadrilaterals, one interior angle is more than 180 degrees, and you can see that here at point B. So one interior angle is greater than 180 degrees. And one of the diagonals will lie inside and one will lie outside. For instance, here is one of the diagonals inside, and here is the other diagonal connecting the opposite vertices, which is outside the shape. The interior angles of a quadrilateral always add to 360 degrees, and this can be demonstrated in a few ways. Firstly, by pencil pushing. If we take this pen lid as facing up, and here I have a quadrilateral I've pre-cut, and I'm going to start it in this angle. If I trace the shape going up, cross, down, move, and I finish back where I start, you can see that the pen lid actually did a 360 degree turn, or one full turn, proving that the angles, or demonstrating that the angles add to 360 degrees. The second way to demonstrate that the interior angles add to 360 is by simply using a protractor. If I measured all the angles of this quadrilateral, we would see they add to 360. In fact, if I create any quadrilateral using a protractor, I would see that the angle sums add to 360 degrees. The third way is tearing the corners. So I'm going to just tear off the four corners of my quadrilateral. And now they're all separated, and as a jigsaw puzzle, I'm going to put them back together to see what they equal. So these two angles are a little less than 180 degrees. And now, what's a good guess there? Around 270 degrees. And when I put my last piece of the puzzle together, you'll see that it forms a full revolution, or 360 degrees. The fourth way is looking at the sum of triangles. Each quadrilateral can be seen as two triangles. For instance, I could take this quadrilateral and I've got triangle 1 and triangle 2. Or I could take this quadrilateral and separate it with triangle 1 and triangle 2. Since each quadrilateral is made up of two triangles which have angle interior sums of 180 degrees, the angle sum of a quadrilateral is 360 degrees. But let's have a look at a proof. Here I've got a diagram of quadrilateral ABCD. I'm going to connect the diagonal AC. So our top triangle is now triangle ADC, and our bottom triangle is triangle ABC. Looking at the top triangle ADC, the interior angles are angle D plus angle DAC, which would be in this position here, plus angle DCA, being in this position here, would all equal 180 degrees. Similarly, triangle ABC, we'd have angle B plus angle BAC in this position here, plus triangle BCA in this position here, equals 180 degrees. Now if we add these two together, we could take it as angle D plus angle B plus, let's put these two together, angle DAC being here and angle BAC being here could also be known as angle A. Putting these two together, angle DCA being here and angle BCA being here could also be known as angle C. 100 and 180 is 360 degrees. That is, angle A, B, C and D all sum to 360 degrees. Now we can use this knowledge in finding an unknown angle in a quadrilateral. For example, in this quadrilateral we have 70 degrees, 120 degrees and 140 degrees, and we're asked to find theta. We know that theta plus 120 degrees plus 140 degrees plus 70 degrees should all equal 360 degrees, being the sum of the interior angles of a quadrilateral. Therefore, theta plus 330 degrees equals 360 degrees, leaving theta to be 30 degrees, using the interior angle sum of a quadrilateral.